Let's do another example of the pairwise comparison method. So let's take this new data here. This was the first example in the section in the packet and figure out between A, B, C, and D who's going to win. And let's just say this is the same situation. We're trying to figure out a class president. It's just a different set of voters and see what would happen. And actually, in this case, we have 4 candidates, so there's going to be 6 matchups. And again, it's going to be just A versus B. What I like to do is start with each pair, and then I can do the mathematical comparison after I get my things set up. And as you know, as I probably have said too many times already, you don't have to do it exactly as I do it. If you can figure it out without doing it this way, that's totally cool. What I just urge you to do is make sure to show your work on an exam, because let's say that you get the answer wrong. If you're not really showing your work, it's hard for me to know, do you actually understand this method? But if you're actually showing your work, that allows me to sort of see, okay, do they really know what they're doing? And I'm a big believer of partial credit for work. What to me, the answer is not so important as is the process. So if you're showing all your work, even if you make a little mistake, that's not a big deal. You're going to get an A if you understand everything, even if there's some little mistakes. And maybe I won't guarantee an A because there is a little bit of a multiple choice element, and it's not there's if you make too many mistakes, right, that adds up. But if you catch my drift, I try to reward understanding in the process more so than just the right answers. Anyways, let's just go through it, and I'm going to try to speed this up a little bit. So between A and B, it looks like B is going to come out on top there, because that would be 14-7. And as I was saying before, it can be nice to know how many total we have to make sure that I'm not screwing up the outcome. But yeah, that would be 20, 21. So yeah, that's adds up correctly. So that's good. And Ben's going to win, or this is a totally different problem, but let's just assume again we have 4 candidates: Art, Ben, Kathy, and Debbie, whatever their names are. So then between A and C, it appears as though A is going to win these two, C is going to win these two, so that would be 13-8 in favor of A. Then between A and D, it's exactly the same, 13-8. And so A will win that one as well. Between B and C, we've got 7. And what I kind of like to do is add them all up as I go. So C is higher on all 3 of those columns. That's 15. And once I do one, the other one should have obviously all the rest of the votes. So you can focus on just one of the 2 at a time, who's higher, and then that implies that B should have the remaining 6 votes because it's 21, if that makes sense. And anyways, between B and D, again, like if I'm applying that train of thought, I could just focus on, say, D. D is higher here and here, which is 10, and B would be the rest, which is 11. Or circling it as I was doing before is probably better, but there's ways to do this in your head and be a lot faster. This one was very close, but B does win. And I wanted to remind you, if there were a tie, let's say this was 10-10 instead, then instead of circling it, I would just, you could maybe circle both of them or something. But when we're doing that final tally, wins and losses, a tie counts for half of a point or a half win. So imagine that B and D did tie. B would have 1.5 wins, so 1.5 points in the final tallying system. And then between C and D here, D is higher here and here. D is definitely going to win. That's 13-8 as well. And then our final ranking is determined by the number of wins. So notice that A has 2 wins, B has 2 wins, oops, C has 1 win, and D has 1 win. And so if you're wondering, well, how do I make a decision here? Well, this would just end up being a tie because both of those 2 candidates had 2 wins in the method of pairwise comparisons, so we don't really have a way of breaking the tie and determining the answer. This is an obvious weakness of the pairwise comparison method, and in tournaments in general, is if people have the same record, like say someone's 7-2, 7 wins, 2 losses, or whatever, and there's likely to be others that have the same record. How do we differentiate them, and how do we determine it? So another way that you could actually make a decision is by looking at all of the methods and kind of comparing, okay, what are the different ways, what are the different circumstances we get here, and what's a logical choice? But what I want to make clear is that there is not a definitive answer, and it's not just about the data, it's about the method of determining it as well.